Dancing with data. Today we are going to talk about DAX optimization. Right? You know DAX. You have started working with DAX. You know all selected. You know remove filter, and also you got to know that there are different ways to yield or to get the same result. But which is the best way? Because if you are working with few thousands of rows or few hundreds of rows, it won't matter. But when you start working in the real project with big data, it matters.
The very first suggestion is to filter columns, not table. Let's try to understand this with an example. Well, calculate is one of the most favorite DAX child, which is being used to change the filter context. This DAX calculation is a common one. This is a common DAX calculation which will help you to get overall sales or total sales. Basically, this all function will remove all the filters from the table and give you the total sales. Now, since we are removing all filters from the entire table, performance can be heavy as we are wasting the resources from the table which is not necessary. Now there is another option where you can remove filter only on the region column, again using all function. So I'll just come back. So instead of order, I'll put the column name, that is region. Sorry for that, I'll just say region, and we are talking orders region. That's it. So there is no difference, means you again get the total sales. Well, this is better from the previous way, but it still references a column, or say it still returns the dataset. The best option in this scenario is remove filter, as we are using calculate DAX function. Now the best part is it clears filters without returning a dataset. And the best use case is where you simply need to remove filters without referencing data, which is exactly our use case. So this is the best and most optimized option for us in this use case. The next one is filter versus direct filter. That means that you are using filter explicitly to filter, or else you are using the direct condition. The first condition is that, or say the only condition in this scenario, the use case number 2, we want to retain only those order IDs which are having sales more than $10,000. As simple as that. Again, we are using calculate function, we have the measure, and after that we are using filter. And this filter function creates temporary table, and it makes your report slower because temp table increase computation time. So use it only when you have complex conditions, not in our case. So the optimized version is this one. Calculate order sales, as simple as that. Order sales greater than 10,000. No need to create those additional temporary table using filter option. This is a straightforward filter. Do not use filter function over here. So go with this condition because it gives you faster access. Direct conditions are optimized by DAX engine. Remember that. Best use case when filtering single column conditions efficiently. That's what we are doing here. We have a single column condition. The next one is summarize versus all select. Requirement is to get profit by category. The twist is we don't have direct profit, so we need to have subtraction between sales and cost. Generally, we do this to avoid excess number of rows scan, but it can backfire because in this case as well, you are creating a temporary table. So you are creating a temp table, which is not good anyways. And now you require iteration over this new table. And because of the above two reasons, performance impact is quite slow. Not in best R case, but maybe for explicitly grouping data. So here is another way to do it using all except. And the advantages are no temporary table needed. So in this case, we are not creating any new temporary table, but it modifies the filter context dynamically. In other words, filter is only applied to category. And that's it. And this is best in adjusting filters in calculate. That's what we are doing. The next one is SumX with if versus calculate with sum. Before we move further, let's define total sales, which is sales into quantity. Make sense? So this is the first approach where here we are making use of SumX, which is a row by row iterator function, and these functions can be resource intensive because of the same reason, row by row. Basically what we want here is to get sales output for only those categories or products for which quantity is greater than 10. And that's why you see one null over there, because for that very particular category and product combination, you have only 10 as the overall quantity. Not only that, SumX itself an iterator, and after that, in the second parameter, we are giving if else condition over there. Anything like if or switch is not good because it is like filtering in the loop. So that's the problem. It iterates row by row, checking condition for each row before multiplying. And hence it makes the overall process slower. And also I talked about the in loop filter, which is not good. So the best use case for this would be when you really need row level calculation, which is not needed in our case. Instead, we can use simple calculate function. Well, No iteration in this case. It applies filter to modify the context before summing. And this will make it faster, reducing any unnecessary iteration. And the best use case is when filtering aggregated values efficiently. And that is our case again. Last but not the least. Now, if you have the option to count the number of employees, so do not make use of customer email when you already have any number like customer ID, or even you can create a surrogate key. And the simple reasons are that first of all, it has a simple data type, integer versus text. It is easier to compress and index. And anyways, comparisons are faster with numbers than string. So just revise these 5 best practices with DAX, and we will meet again to discuss another 5. If you really want, just let me know in the comment section. Till then, keep on dancing with data क्योंकि data ही दाता है क्या तुमको सब कुछ आता है